Alright guys, for the hyperbolic functions, which is sine of 80 and cosh of 80, we know we can express these hyperbolic functions using exponents, and this is what it's going to be. If you are unclear of how you can do this, just drop a comment and I'm gonna explain it to you. I can make a video. I'll send you a link to another video I've made earlier where I explained how this came to be. So with this already established, the Laplace transform of sine 80, which is going to be the integral, the same formula from 0 to infinity of sine 80 e to negative st the t. And if we replace sine 80 with the exponential expression, we have half a bracket e to 80 minus e to the power of negative 80 all over 2, and then e negative st the t. And we simply distribute this, and if we do that, we can pull out this value of 1 over 2, and we're going to have 1 over 2 outside the integral because it's not dependent on t. Will give us, if we multiply, we have e to the power of 80 dot e to the power of negative st, then minus e negative 80 e negative st all the t. Okay guys, and simplifying this further, we're going to have our 1 over 2 stay out, integral 0 to infinity. We'll have e to the power of negative s minus a. I can write this better. Negative s minus a t minus e to the power of negative open bracket x plus a t all the t. And we can actually separate these integrals, and we'll have 1 over 2 upon the big bracket into the integral of 0 to infinity e to negative open bracket s minus a t the t minus integral 0 to infinity e to the power of negative x plus a t the t. And if you've been following this video, remember when we solved the integral from 0 to infinity e to negative st the t, and this just gave us 1 over x. So if you apply the same solution to this, you find that here we have x, but here is replaced by x minus a, and you can easily replace this x here by s minus a, and that will be the integral of this. So with this in mind, you find that what we have here will now be equals to not this whole solution, this whole expression will just be equals to 1 over 2. This guy is just 1 upon the bigger bracket, then open the smaller bracket, 1 over x minus a, minus here x has been replaced by s plus a. This was minus 1 over x plus a, and then you close the bracket. And if you do this, solve this, you're going to have that this is 1 over 2 into x plus a minus x plus a all over x minus a x plus a, and this will give you 1 over 2a all over x squared minus a squared, and you can cancel out the 2, and we'll have a over x squared minus a squared. So this tells us that our sine of at, Laplace transform of sine of at, is a all over x squared minus a squared. And this is done. Now we're left to find that for Laplace transform of cosh at, which you can find for the very same method, which is, I'm just going to do it really quick. So if you didn't follow the last time, you could just walk with me. St, the t, which is integral of the exponential expression, e a t plus e negative at all over 2 e negative st the t. And if you open up this expression, if you distribute the exponents, you're going to have, you can bring out 1 over 2 here as usual, and you're going to have e to the power of negative open bracket x minus at plus e to the power of x plus a t all the t. Okay guys, and with this you have 1 over 2, open a bigger bracket, you can separate the integrals, 0 to infinity, e to negative power of negative x minus a t the t plus integral 0 to infinity e negative x t the t. And we know what that says. This is just 1 over 2 into this whole guy here is going to give us 1 over x minus a plus this is 1 over x plus a. And if you do the algebra involved, this is just going to give us x plus a plus x minus a all over x squared minus a squared. And this is simplified. You're going to have 1 over 2. You're going to have, just a second, 1 over 2 into 2x all over x squared minus a squared. And the 2 can cancel this, and you have x over x squared minus a squared. And this is a Laplace transform of cosh at, which is hyperbolic function. So this clearly shows us that cosh at, the Laplace transform of cosh at is x over x squared minus a squared, and that of sine at will give us a over x squared minus a squared. So in the next video guys, we're going to solve examples that involves both sines and cosines, combining them with different functions. Alright guys, see you in the next video. Thank you and do subscribe.